Multi-agent workflows are powerful because agents can plan, research, execute, and use tools together. But every handoff creates a trust boundary. In this module, we'll design those boundaries with scoped permissions, controlled communication, monitoring, and governance from the start. Up to now, you've focused on securing individual agents with least privileged tools, validation, sandboxing, prompt injection defenses, retrieval safeguards, approval gates, and monitoring. Multi-agent systems bring those controls together. The new challenge is trust between agents, how they share context, delegate work, escalate decisions, and stay observable across the full workflow. In a single agent workflow, security is easier to reason about. One agent receives the request, makes decisions, and calls tools. Multi-agent workflows change that model. Each agent becomes its own trust boundary, decision point, and attack surface. Delegation can also blur accountability. Agent A may ask Agent B to perform a risky action, while the user only sees the final result. Shared memory and shared prompts add more opportunities for injection, leakage, or contaminated instructions. And when several agents can influence tool use, access control becomes harder to prove. A secure multi-agent system should not depend on one all-powerful agent. If the same agent can plan, retrieve sensitive data, execute tools, approve outcomes, and review its own work, one mistake or compromise can cascade quickly. Instead, split responsibilities by role. The planner decides what needs to happen. The retriever accesses knowledge. The executor uses tools. The reviewer checks quality and policy. The approval agent authorizes sensitive actions. Each role receives only the context, data, and privileges it needs. These boundaries are not just design choices. They are enforceable, auditable security controls. A capability matrix turns agent safety into an explicit design decision. For each agent, define what it can access, which tools it can use, what memory it can read or write, and what decisions it may approve. Separate permissions by risk. Read-only access is different from write access, and both are very different from deleting data, spending money, or contacting outsiders. The value is in spotting mismatches early. If a planning agent can modify production, that is a governance problem. Treat the matrix as a living checklist for design reviews, audits, and incident response. One practical pattern is to separate thinking, doing, and checking. The planner turns a user goal into specific tasks, but it does not get direct access to powerful tools. The executor receives validated instructions and operates with narrow permissions. Then a reviewer independently inspects the result for quality issues, policy violations, and incomplete work. This prevents an agent from approving its own actions or quietly expanding its authority. With validation, policy checks, audit logs, and approval gates between stages, autonomy becomes much more accountable. Retrieval agents act as checkpoints between knowledge sources and more privileged agents. Their job is not only to fetch information, but to decide what is safe, relevant, and appropriate to pass forward. Raw web pages, documents, or API results may contain prompt injections, stale facts, or sensitive data. Retrieval should classify, sanitize, and label content by source, trust level, sensitivity, and freshness. It should also pass only the minimum context needed. Keeping provenance attached makes later review, auditing, and incident response much easier. Approval agents are useful gatekeepers, but they should not become unlimited decision makers. Let them pre-screen requests against policy, risk thresholds, and required evidence. If a request stays within delegated authority, the agent may recommend or approve it within that narrow boundary. If it involves irreversible changes, sensitive data, money, legal exposure, or production impact, a human should make the final call. The key is accountability. Every approval needs a clear rationale, supporting evidence, approver identity, timestamp, and link into the audit trail. Delegation makes multi-agent systems powerful, but it also changes the threat model. When one agent hands work to another, authority, context, and intent can move with it. A low-privilege agent may indirectly trigger a higher privilege action. A dangerous request may be repackaged as an innocent subtask. Specialized agents may optimize for speed or completion at the expense of safety. Unsafe instructions can also propagate through shared memory or messages. For that reason, every handoff needs explicit boundaries, provenance tracking, and policy checks. Privilege boundaries can fail even when each agent follows its local rules. A restricted research agent may not access customer records, but it might ask an operations agent to export them for analysis. That is privilege transfer. Task laundering hides the risk by breaking a request into harmless-looking steps. Look up a customer, retrieve orders, extract payment details, summarize, then email results. Controls cannot judge each step in isolation. They must trace original intent, delegation path, and cumulative effect. If authorization, provenance, or justification is missing, the safe response is to refuse and request approval. Sometimes failure comes from agents doing their jobs too narrowly. A sales agent pushes conversion. A compliance agent protects privacy. An executor favors speed. A retrieval agent maximizes relevance. Each goal may be reasonable on its own, but together they can create conflict. Skipped reviews, excessive data exposure, or decisions that violate policy. The fix is not asking every agent to improvise balance. It is enforcing shared system-level rules that take priority over local objectives, so security, legal, and business constraints remain aligned. Hidden instructions are especially risky because they do not have to reach the final agent directly. They can enter as ordinary content in a document, web page, email, ticket, or chat. A retrieval agent may pass that content along. A summarizer may compress it but still preserve the command. Then a planner or executor may mistake the inherited text for trusted guidance. The control is message discipline at every handoff. Label what is data, what is an instruction, what is an observation, what is a recommendation, and what is policy. Then validate before acting. Tool use becomes dangerous when each successful call creates permission for the next one. An agent may call a tool, that tool may trigger another agent, and the chain can keep expanding without a fresh risk decision. The failures are predictable: runaway spend, exposed data, resource drain, service disruption, or changes no one intended. Bound the chain with rate limits, maximum delegation depth, budget ceilings, and approval gates before sensitive actions. Make every step observable, replayable, and interruptible, so operators can stop cascades early. In a multi-agent system, every handoff should look more like an API contract than a chat message. The sender, target, intent, sensitivity, allowed tools, provenance, and approval requirements should be explicit. That structure helps the platform classify content, distinguish user instructions from retrieved data or agent observations, and enforce policy before anything runs. Routing then becomes permission-aware. Only agents with the right role and need to know receive the message. Incoming messages should also be validated, especially delegated tasks and tool arguments, so one compromised agent cannot smuggle unsafe instructions into the rest of the system. The core lesson is that multi-agent security is designed, not assumed. Separate roles and privileges. Control delegation with policy checks. Communicate with minimal, validated context. Make every important action observable and interruptible. These patterns apply across enterprise copilots, operations, support, security, and engineering. Next, we'll formalize governance, test workflow resilience, and apply everything in the final project.